There's a thing bigger than you that you're part of, and you wind up aligned to it. People align to their families, and your behavior is aligned with that family. And that kind of alignment, there isn't any closed form solution for. There are certain kinds of problems that can be solved with closed form solutions, and thanks to Goodell, we know that there's kinds that can't be. And it turns out that aligning to a greater whole, aligning to a thing in the world, an actual thing out here, that's not a conceptual problem. That's a real thing. There's this non-stationarity to that. Whatever you think, whatever you write down as your description, whatever meta-generative process you use to generate the process that generates the process that generates your description, the thing we know about models is that models are useful and all models are wrong. And so whatever model of the good, of constraint that you wrote down, you were wrong. If you've aligned to that, now you've aligned to the wrong thing. And what you want is the thing that people do, which is people, they notice like somehow, this is a magic trick nobody quite gets yet, but I think we're getting close. They notice, I know my loss function says that this is good. And I know I'm scoring very high by the rules that I think I'm supposed to follow. And yet, this doesn't feel right. Something is wrong. This is that inner light that causes us to do things like invent the idea that values and morality exists. Why do people go around talking about there's morality? Where did it come from? Well, inside they felt that like, well, these things are right and these things are wrong, and then they tried to explain it. And so our mission at Softmax is organic alignment, which is to find the principles that underlie this, both the principles of how you engineer it and also how you detect it, how you find it if it's happening. We do this with machine learning simulations with lots of agents where we can see if they're aligning. But like, I think the most important thing about the work that we're doing isn't necessarily the simulations themselves, but rather that we are increasingly able to tell if the agents are aligned in the first place. And to give you an articulation of how you would know if you had agents that were part of a whole and how to tell if they were aligned to that whole or not. Where does this morality thing come from? It comes from the fact that sometimes we interact, first of all, that we can see that we are part of things. We can tell this is my people, these are my tribe, this is my family. And I can tell that they belong to this team as distinct from that team. And we can just see that. Some guesses as to how, which I'm happy to get into, but like we don't really know. And then you can see that sometimes when I act, this thing I'm part of suffers. Like maybe I feel okay, but I can tell that this thing isn't healthy. I can tell the team is suffering. And so that we can see this community is healthy or this community is not healthy. We can see this is flourishing or not flourishing. This ecosystem is flourishing or it's like dying. And we can just see it the way we can see whether a ball flies or not, which is why no one had to develop the 10 Commandments to be able to know that murder was wrong. And why we developed the 10 Commandments to say, no, we all know, we can all see that murder is wrong. The conceptual understanding of what morality is, that comes after the seeing. Just like Newton's ability to like conceptually understand what causes things to fall comes after the like seeing of falling and the experiencing of falling.
Is there like any findings that you could share from your like technical work?
Yeah.
That's sort of like, like maybe some aha moment that really...
I think the coolest one that I realized most recently is that you can see the rate of change in the average weight in the network as the pressure. It's like there's a thermodynamic model of any learning system that says every weight is like moving at some rate. And those are particles. And they're particles that interact with the other particles, which means it follows the ideal gas equation. And their motion impacts the motion of things around them. And so the more there's change in this part of the system, the more it propagates into change. Like if you change some of the weights a lot, it's going to cause the other weights to want to change too. And so there's a sort of a conservation law around this. And it really does, it's like if the system, to the degree the system already anticipates the information it's getting, you get shallow gradients, which means you get less energy in the system, which means the pressure, very little learning happens, the pressure is low. And to the degree that you are not anticipating your predictions correctly, they're like coming in and these energy gradients are hitting you in the training, and they're steep gradients, and it's downhill, and lots of change happens, and then the inside of your system's in a lot of motion. You can literally measure the pressure of the system by the per training per training, gradient descent run, the average per weight delta change, and you can measure then the volume is just like how many weights there are. If you imagine it I like to imagine it as like a balloon or something, like a stiff balloon, like a hot air balloon or something. If it gets too hot, if you have the gradients are coming in too fast, it overpressurizes, and eventually you get catastrophic forgetting, like it pops, and whatever structure is there is now gone and worthless. And if you have your learning rate if you have the gradients are too shallow, and things aren't changing enough, and the pressure starts to drop, but the environmental pressure, like the actual things around you, are still in motion, the whole thing collapses and you get mode collapse. That's what mode collapse is your pressure, literally your pressure dropped too low and your thing collapsed. Your model collapsed into a single state because it didn't have the internal pressure to keep itself open anymore. And like, they really are these little, in some sort of like epistemic space where confidence in belief is mass, and motion in belief is sort of like, is motion, literally energy. There's like a physics, and every learning system is like it has a pressure, and like if it overpressures, it pops, and under pressure, it collapses. And as you get more and more conserved weights, because it's doing the learning, there's a phase shift internally where it's going from this sort of like high energy state to a non-solid, basically it's turning solid. And as it turns solid, the amount of remaining space in the balloon like gets smaller. So if you have the same amount of weight energy coming in, it's going to pop the balloon more easily. You are building up towards catastrophic forgetting if you're not careful. People have this impression of machine learning, like there's a great XKCD strip where it's like, how do you do it? Just throw more data in the pile and like stir it until it gives you the right answer. That's the alchemy approach to machine learning. It's true, but like machine learning is not magic. It's physics. And actually, I think that's the best analogy for it. It's physics when you go up one level meta, but it's literally a thermodynamic system. Maxwell's demon proves information is thermodynamic energy. There's no difference between them. So it's actually just a thermodynamic system that just happens to be running inside your computer in a way that doesn't look like a gas, but like there's kind of actually like in a very meaningful sense, there's like an epistemic balloon somewhere, and that's your model.
I just want to tap into your entrepreneurial experience. I was a founder. I founded a company, so I went through some like founder journey. But now, to be honest, I feel like really lost, like thinking about what I want to build next, because I feel like whatever I decide to build, OpenAI will just destroy me. So, what advice you could give to people who are thinking about what to build, what could be useful for humanity, but want to have some defensibility?
When uncertainty goes up, what we're experiencing is like your predictive model isn't bad yet. So you're not experiencing actual distress because your model is still predicting its observations well. What you're experiencing is you no longer expect that to remain so. And so you have this trepidation of like, it seems like my model's about to get really bad, like soon. There's two possible reactions to that are both wise in their own way. One is to hunker down and to say, like, what do I know? Who do I know? And to invest in relations. If you can't save meat for the future, and you don't know, and hard times are coming, the best place to save that extra meat is in your friends' bellies. If there's a way you can do something that is for the people who you are most directly connected with, whether it's, and that's like, so basically think local, like that could be local to the United States, it could be local to San Francisco, it could be local to your community, but like as you bring it in to people who know you and remember you, you're investing in something that is very durable, which is the sort of, the echo pointer state you leave in the world, the little you that lives inside of everyone else's heads, that's the model of you. You're investing in that model. And so I recommend investing in that model. That's one thing that's always a good idea when things are uncertain. And the other thing you can do is, the other wise thing to do is to just increase your tolerance for risk a lot. Not like your tolerance for like immediate risk, but like your tolerance for like, do I think this will work? You don't know, but that means that you don't know if the safe things will work or the risky things will work, which means you might as well do the risky thing because the safe thing isn't safe either. So you should just be like trying things that are way more crazy than you think they should. Like that's, most people, when I see them starting companies, the main thing I'd say is like, you should probably be more local. And also you're not nearly crazy enough. Like what's the thing that like probably will not work, but if it did work, it would be amazing. Or like, you don't even know what it would be like. That's like a good idea right now because the predictable things are also, I don't know if they're going to work or if they're like, it's all the same. So you might as well be bold.
So very, very, very crazy,
Yes.
like
Yeah,
thing.
go bold.
Yeah, yeah.